Welcome to this Tutoring Center video. You can follow us on social media if you'd like to. I will be presenting today. Today's video is on how to solve a convolution problem. Let's solve this convolution problem. The first step in a convolution problem is to do a change of variable. The reason we do this is because we need two variables, one for the time index and one for the integration variable. By convention, we use tau as the variable of integration and we use t as the time index. So we will change both x of t and h of t into x of tau and h of tau. All we did was change the variable from t to tau. The graphs still look exactly the same. The second step is to pick one of the signals and flip it across the vertical axis. We can pick either one. We will get the same answer either way. I'm going to choose h of tau because I think that will be easier. The final step is to take the flipped signal and slide it across the other signal. That is what convolution is, visually speaking. We slide one signal across the other one and see what comes out. That is what the t variable is representing, how far h of minus tau is slid across. In this picture here, t equals 0. Because the original h of minus tau is not shifted at all. Let's now write the equation for convolution. We can simplify this equation by recognizing that step functions are just equal to 1 or 0. So when multiplying by step functions such as u of tau or u of t minus tau minus 2, we are just multiplying by 1, except for when there is no overlap, in which case we are multiplying by 0. So we can remove the step functions from the equation because they are just multiplying by 1. And now we can determine our limits of integration. To find our limits of integration, let's go back to the visual representation again. Let's plug in a value of t for which there is definitely no overlap, for which there definitely is overlap, and then draw the signals. I'm going to choose t equals 5. As you can see, for t equals 5, the overlap begins at tau equals 0, and ends at tau equals 3. The lower limit will be 0, but the upper limit will vary depending on what t is. For t equals 5, the upper limit is tau equals 3, or tau equals t minus 2. We can conclude that the upper limit will always be t minus 2, but if you are not sure, then you can plug in another value for t and see where the overlap is. If you choose t equals 6, then you will see that the overlap region is from tau equals 0 to tau equals 4, which is once again t minus 2. Now that we have our limits of integration, we can plug them into our formula and solve. This will lead us to our final answer. Remember to include u of t at the end because we know there will be no output before t equals 0.